Hey everyone, this is Jack and I am back. Yesterday I released a video saying that CompBot had been updated before Road to Las Vegas 4 starts, using all the information that I've had from the speedruns for Road to Las Vegas 1, 2 and 3. I did a quick walkthrough of my speedrun yesterday for Road to Las Vegas 1. Today I'm doing a walkthrough of Road to Las Vegas 2 where I did question 7. So, no further ado, let's jump to my screen. This case is Who Done It by Harry Watson. You'll notice this is the second Harry in a row that we've had a case from. Yesterday's case was by Harry Grass. And I'm going to run you through how I solved level 7 on this one. So first thing I do in every single run is I'm going to press Ctrl-Shift-G and CompBot will automatically generate everything that I need in my file for me. So there's some case inputs for bonus questions. These are the different levels. I also have the information sheets. In this case, I'm going to put a name in for that one, and then I'm going to do a lot of my work in this correspondence sheet before coming back to level 7 to input the answers. So first, I'm just going to put a quick sequence up here. I'm going to go sequence. We want one row. We want the maximum length of this range of cells, which is called correspondence, because of the naming that we did with this setup macro. So that gives me a range from 0 as my minimum up until 1 less than the maximum length. And what I'm going to do there is I'm just going to give that a name quickly. Now I'm setting up a base array to work from, because I do a lot of array manipulation in this one. This is just linking again into that named range correspondence. And the first step I'm going to do is I want to find the along shift, which means I need to find out which day of the week is used here. So if I do a Ctrl-Shift-R, that gives me a fresh array to work from. And I'm going to keep everything to the left of the space. So I'm going to wrap it with an if error text before space command. And that gives me all the words. I'm then going to split by character, and these words should spell out days of the week once you've shifted them, but we don't know how to shift them by. But what we do know is we now have this information. I'm then going to convert these into Unicodes. So this gives me the number they're with, and I've done this before doing anything else because those hash values over there, I'm actually going to utilize that by wrapping in an if error, then blank. So now those are blank cells, which means I can run my align array to right, which now shifts the entire array over to the right, and it means I can keep these last two columns. The reason I'm keeping those is that that will always be the letters A and Y, and the difference between those should be 24. The difference here will be 24 less whatever the shift is. So what we're going to do is we're just going to keep those last two columns, and then we're going to get the difference between these two columns, and that gives us the difference in addition to the 24 difference between the letter A and the letter Y. So I am then just going to add 24 to that. That gives us that. I'm going to make it absolute by wrapping in an abs, and this gives me all of the numbers from 0 to 6 representing days of the week and the along shifts that are actually used. So I'm going to name this range along because I'll be using that later on. Now, to get what day of the week it is, I'm actually going to use this lambda called tday, which is text day, and that will pick up the tday for all of these long values, but I've added 1 because these are running from 0 to 6. I want it to run from 1 to 7. And that gives me the day of the week that's been represented here. I only need to know the first letter of that in order to work out how much to subtract from the Unicode. So I'm going to split by character, same as I've done in the last one, but only keep the first column. That gives me the first letter of the word. I'm then going to convert that to a code, and I know that the Unicode for that is then 70 for Friday, and so on. Again, we're going to work with an array. So I'm now going to work out what the base shift is to get me up to that letter F, because I know that's a letter F now starting that first row, and so on for the rows below. So again, we're going to split by character, we're going to keep the first column because we're only interested in the first column at this point. We're going to wrap that in a Unicode. That gives us the Unicode for that character, but we also know that it's the letter F, so we can subtract what we've got from the previous column. So this one is the Unicode for F, and that gives us the base shift. If you read the question, there's a base shift and a long shift that are applied to each of these. So that is now my base shift. We can now then, from that, we can look up which person it used, because in this people sheet, each person used an exact shift number. So if we go and find this number 10556 in the people sheet, it will tell us who the sender was that committed the crime, send the message admitting to committing a crime. So I'm going to use the lookup RC function by row because I'm using an array of it, because I'll probably do this whole array, and I'm going to look in the range people, which is the used range in the people sheet. That gives me a row and a column number. I'm only interested in the column number because I want to know who it is that sent it. So that's the column number. I'm going to also subtract 2 because there are 2 columns at the start of people which don't have names in them. And then I'm going to get the index of the range sender, which I've set up earlier, row number 1, column number, what we've calculated, and that should give us all the names. We're going to go back, and now we're going to find what each person actually admitted to. There's a lot of manipulating arrays in this one. So we're going to split this whole thing by character. We're going to convert it all into Unicode. Then we're going to subtract the base shift. And then we're going to subtract the along shift multiplied by the sequence that we worked out from 0 upwards. And what that will do is we'll apply no along shift for the first cell, 1 along shift of 4 for the second in the first row, changes by row, and doubling that up and then tripling that up in each cell. And that gives us the original characters. There are some that are negative numbers, that's fine, we're going to deal with that in a second. I'm going to reverse these back using a wrap in Unichar. This gives us some letters. We're going to replace errors with spaces. And then we're going to concatenate this whole thing by row, and I'm going to name this area trans because that's our translation. We can now go into level 7. There are some number 2s, so I think the quickest way to do that is to just replace a 2 with a space and do that. Now we can go look up these in those translations, and the way we have to do that is to use a find. So we're going to do a find on the first cell in the range translation hash. That will give us a bunch of errors as well as a number in one of the things. So we're going to replace any errors with 0, and then we're going to do an XLOOKUP of the number 1 against this list and returning from the name list that we created. And we're going to do a match mode where we have to find the exact match or the next large item. So we're not looking at the zeros, we're looking at the one where it's actually been found. And that gives us a nice little error. So let's just have a quick look at what we have done here. I think it's just the named range that I used in this one. So I didn't bother to put in the named range. It's now in there, which means that gives us an answer. Great. Autofill down to finish it, and that is the end of level 7. So that's how I did level 7 in the speed run. In this particular case, we did beat Dimit, so I'm pretty proud of that one. Thanks for watching, and come back tomorrow for speed run 3.